The following is a presentation of Aviation Maintenance Publishers' Video Graphics Division. Aviation Maintenance Publishers is dedicated to professionalism in the education and training of aviation technicians. To help meet the increasing demand for skilled personnel in the aviation industry, we have produced this series of videotaped programs on the practical applications of your technical training. These programs are designed to complement the personal instruction you are receiving. The information contained in this series is intended as a guideline and should be used in conjunction with the appropriate Federal Aviation Administration documents and manufacturer's publications.
The Cessna 206 aircraft is typical of today's aircraft using a reciprocating engine, which requires cylinder compression checks. One of the most common causes of a power loss in any aircraft engine occurs as a result of a loss of compression. The cylinder compression test determines if the valves, piston rings, and pistons are adequately sealing the combustion chamber. The first step in performing a differential compression check is to select the proper tools for the job. You must also make certain to have on hand an up-to-date manufacturer's manual containing the latest revisions, as well as a recent copy of the Federal Aviation Regulations Part 43. Make certain that all measuring tools have been calibrated within the allowable time limits as prescribed by the FAA. Before any attempt is made to perform the compression check, it's important to bring the engine up to normal operating temperature. Before beginning any work, be sure that the ignition switch is in the off position. This will prevent any accidental firing of the engine when the propeller is turned. As a further precaution, always placard the switch to inform other personnel that work is being performed on the engine. To perform the compression test, remove the cowling. The test should be made as soon as possible after the engine is shut down. This ensures that the cylinder parts are completely lubricated. During engine buildup or on individually replaced cylinders, spray a small quantity of lubricating oil into the cylinder and then turn the engine over several times to seal the piston and rings in the cylinder barrel before the compression test. Remove the most accessible spark plug lead from each cylinder. You must properly support the lead when removing it from the spark plug. Take care to pull the lead straight out and in line with the center line of the plug barrel. If a side load is applied, damage to the barrel insulator and the ceramic lead terminal may result. Always place a protector over the ceramic lead terminal to protect it from damage after it's been removed. Select the proper size deep socket and breaker bar for spark plug removal. Apply a steady pressure with one hand on the breaker bar while holding the socket in alignment with the other hand. Failure to hold the socket in correct alignment will result in damage to the spark plug. It's a good practice to always place all spark plugs being removed in a numbered rack. This procedure simplifies troubleshooting if one or more spark plugs are noticeably different in appearance at the firing end. Used spark plugs tell the condition of the cylinders. All the top spark plugs have been removed to facilitate turning of the prop. The compression stroke can be determined by placing your thumb over the spark plug hole of a given cylinder. Number 1 in this case. Compressed air will blow your thumb out of the hole as the crankshaft is turned counterclockwise as viewed from the front of the engine. When the rocker box covers are removed, valve action can be observed. At this time, both the intake and exhaust rocker arms may be checked for free play, indicating that the valves are seated. After the compression stroke has been located, screw the adapter firmly into place, making sure that the O-ring has been installed on the adapter to prevent leakage. The differential compression tester checks the compression of an aircraft engine by measuring the leakage through the cylinders. The design of this compression tester is such that the slightest amount of valve leakage can be detected. The operation of the compression tester is based on the principle that for any given airflow through a fixed orifice, a constant pressure drop across the orifice will result. As the airflow varies, the pressure changes accordingly and in the same direction. Before making any attempt to connect the compression tester to the cylinder, always make sure that the shut-off valve is in the closed position. Connect the compression tester to an adequate air supply. As viewed from left to right, the gauges in the unit are 1. Regulated pressure gauge, and 2. The cylinder pressure gauge. After the inlet supply of air has been connected to the compression tester, adjust the regulator of the tester to obtain 80 pounds per square inch on the regulated pressure gauge. Connect the compression tester to the adapter. As a safety precaution to yourself and others working on the aircraft, always maintain a firm hold on the propeller before opening the shutoff valve. With the regulated pressure adjusted to 80 pounds per square inch and the shutoff valve in the open position, if the cylinder pressure reading indicated on the cylinder pressure gauge is below the minimum specified for the engine being tested, move the propeller in the direction of rotation to seat the piston rings in their grooves. Record all readings for the purpose of evaluation. When checking compression on an engine, use the firing order sequence shown on the engine or in the maintenance manual. When cylinder number 1 has been tested and recorded, the next cylinder to come up on the compression stroke in the firing sequence will be tested. Turn the propeller in the direction of rotation and use the same procedure as used previously. Upon checking this cylinder, you'll note that in this case, the reading on the cylinder pressure gauge indicates a loss of compression. Remove the rocker box covers as previously mentioned and check the valve clearance. At this time, it will be necessary to determine if the problem of low compression is caused by valve blow-by from the exhaust valve, which can be heard at the exhaust stack, or blow-by past the intake valve, which can be detected by a hissing sound through the carburetor, or blow-by past the piston rings, which can be found by air leaking from the oil filler neck. If the loss of compression is due to valve blow-by, it will be necessary to stake the valves. This can be accomplished by tapping the rocker arms several times with a soft-faced mallet to dislodge any foreign material that may be lodged between the valve and the valve seat. After staking the valves, rotate the engine and recheck the compression. If the loss of compression was not caused by valve blow-by, spray a small amount of lubricating oil into the cylinder and the engine several times to seal the piston rings in the cylinder barrel and recheck compression. If the procedure outlined does not bring the cylinder pressure reading to meet the manufacturer's specifications, replace the cylinder. Replace all spark plugs and gaskets and torque to manufacturer's specifications. Install all spark plug leads and make a final inspection for security and completeness. Replace the cowling and make the appropriate logbook entry. Early diagnosis of engine problems will not only save on costly engine repairs, but will assure the operator of a safe and sound running engine.